The next problem has to do with interference, where you have a diffraction grating and you have spacings between openings of 1.7 micrometers, or micro means 10 to the negative 6. And it's got wavelength, it's got light coming in with a wavelength of 971 nanometers. Nano is 10 to the negative 9th. Micro is 10 to the negative 6th. Nano, oops, not milli, nano, 10 to the negative 9th. Okay, and list all the angles of interference fringes. So what we know is that we get interference coming off when the, here we go, here's theta, theta subscript n, the nth fringe. Well, the this is an integral number of wavelengths. For constructive interference, this length is integral number of wavelengths, and we're going to call this d, the spacing between the openings. So what we get is that this angle here has to equal theta subscript n, right here, and n wavelengths over d is the sine of the nth fringe. So we just take lambda over d, so a, one wavelength over d, which is, and by the way, well, I won't worry about it. Just, you can just go to your calculator. 1.7 times 10 to the negative 6 divided by 971 times 10 to the negative 9th equals, I got 1.75, and that doesn't sound right. I got it upside down. Wavelength is 971. Lambda is 971. D is 1.7. So the first fringe is at 34.8 degrees. Second fringe, let's do it right now. I'll show you, go through the process. 2 times the wavelength of 971 divided by 2 times 971 e to the negative 9th divided by 1.7 times 10 to the negative 6th equals. So we got this, and when we do inverse sine, it's an invalid, and so it doesn't work. Okay, so we only have one order of diffraction, one order, yeah. So for this problem, you shoot a laser beam through this diffraction grating, you'll only get three spots, one at the center and one on each side. I've only shown one side. There's another one that'll create a spot on the other side. Well, how many? One. Uno. How many orders are produced? One. So SAB. One spot, one order. And for clarity, you can say 3 spots. That helps your instructor know that you know what you're doing. I mean, that's the whole purpose of an exam.